We're going to do lesson 2.5. We're going to be proving angles congruent. And I am actually really excited because we finally got the whole YouTube video thing down and trying to get lessons. So this lesson will be probably broke up into about 3 to 4 videos, but it's probably one of the most fundamental lessons. It's about all the different types of angles besides working with parallel lines that you will see over and over again. And remember, the objective today is to identify angle pairs and to apply theorems about those angles. And the first one is adjacent angles. And when you think of the word adjacent, you think of next to, right? You're next to someone, you're adjacent with them. Well, we want to think that way about our angles also. So here's our formal definition. 2 coplanar angles with a common side and vertex, but no common interior points. The no common interior points, what it does, it allows us to realize one can't be inside the other one. So if you look at these, you can see how angle 1 and angle 2 are adjacent. They're called the linear pair, which we're going to actually define down below, but they have a common vertex and they share this common side between them. So angle 1 and angle 2 are adjacent. And we're going to angle 3 and angle 4 are adjacent. Notice they have a common vertex, and I kind of scribbled across their common side. So angle 3 and angle 4 are adjacent angles. But now let's look at this diagram right here. This is where we ended up the other day in class. We have angle 5 and angle 6. Now, are they going to be adjacent? Well, we have to think if-then. If it fulfills the definition, then they are adjacent. So what's the definition? 2 coplanar angles. Well, obviously 5 and 6 are coplanar angles. Do they have a common side? Yes. Here's their common side. Now the next one. Do they have a common vertex? No. So I don't have a common vertex because here's the vertex for 5, here's the vertex for non-adjacent angles. And notice I'm not defining non-adjacent, I'm expecting you to realize that means the opposite of adjacent. Hopefully that makes a little bit of sense. Now, here's one of those things that if I could get across for the lesson, it's going to make your life so much easier. In fact, I'm going to zoom in a little bit here. Vertical angles are like one of the most fundamental things in geometry. And their definition is very straightforward, and it makes it really simple to understand. But if we have to know and be able to recognize these at all times, no matter what. Vertical angles are 2 non-adjacent angles, and I'm going to start using the angle symbol again, who are formed by 2 intersecting lines. Alright, that's my warning for 5 minutes left on this video. So now when we have 2 intersecting lines, you see them here, I'm just going to call it line A and line B, who are intersecting each other, we are going to have these angles formed. Now, 1 and 3 are adjacent, 1 and 4 are adjacent. Well, that only leaves the non-adjacent ones to be 1 and 2. So angle 1 and angle 2 are vertical angles. And so we're going to just say they are a vertical angle pair. Now, that means there should be another pair actually. We should always have 2 pairs of vertical angles being formed when we have 2 intersecting lines. Notice 3 is adjacent to 1 and 2, but not to 4. Well, that means 3 and 4, and they're always the ones that are across from each other is another way of thinking about it. So 1 and 2 are across, 3 and 4 are across. They're the second vertical angle pair. So angle 3 and angle 4 are vertical angles. So they're another pair of vertical angles. Now, the other day, we had another name, linear pair. Now, here's the thing I don't want anyone ever to forget. The name gives away what we're talking about, okay? Linear means line. Pair means two. So I'm looking for a linear pair of angles. So angles probably form from the same line. And their definition is really critical too. This is like vertical angles and linear pair. If you don't know these definitions, they'll come back to haunt you over and over again. So here's the definition for a linear pair. Listen to how common sense it is. Two adjacent angles formed from the same line. Think this way, and we've already actually used this. We just called it sum of the parts equal the whole. If I have a line and I have a ray coming off, I form two angles. Angle 1 and angle 2 are what I'm going to call them here. I formed a pair, a linear pair. So angle 1 and angle 2 are a linear pair. So what would be the linear pairs right here? Well, let's think about it. We have a lot of them. We have angle 1 and angle 3, because I could cover up 2 and 4. There's my line. Oh, how about going this way? If I cover up the line, I have angle 1 and angle 4 are a linear pair. Or how about if I cover up the line and go this way? 2 and 4 are a linear pair. Or how about if we go this way even more? 2 and 3 are a linear pair. So basically, I can end up having 4 pairs of linear pairs. So when I have those intersecting lines that made vertical angles, they also made linear pairs. Now, way back the other day, it was way back in the first chapter, we talked about the linear pair postulate. And the linear pair postulate states the following. Two angles formed from a straight angle, or a line, measures have a sum of 180 degrees. Well, let's think about that, how logical that is. We know that a straight line or a straight angle has 180 degrees. So the two angles that make the linear pair, like 1 and 2 right here, add up to 180. Sum of the parts equal the whole. We just knew the whole was equal to 180 degrees. So, like from this diagram up above, let's look at all of our pairs. That means the measure of angle 1 plus the measure of angle 3 is 180 degrees. That also means this linear pair. Remember, we could cover it up, 1 and 4. So we have the measure of angle 1 plus the measure of angle 4 equals 180 degrees. We can keep looking. Angle 2 and angle 4. So the measure of angle 2 plus the measure of angle 4 is 180 degrees. Well, what do we do in the next one? How about we do the next 2 and 3, because I can still have a straight line there. So the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So not that difficult to see. Well, let me get that down, and we'll flip to the next page. Now, we have two other definitions we'd like to get. Complementary angles. You had these probably back in Algebra 1, but we're going to really emphasize those now in geometry. The first one's complementary angles. Two angles whose measures have the sum of 90 degrees. Now, not 3 angles, not 4 angles, just 2. So like here, you can obviously see that these two adjacent angles, angle 1 and angle 2, are complementary to each other because the sum of the parts equal the whole. Measure of angle 1 plus the measure of angle 2 equal 90. Now, here, A and B, notice they're not touching. They could be in different planes, but long as they add up to 90 degrees, they're still considered complementary. And think of complements as short and sweet. So complementary angles just add up only up to 90. Now, the angles are called the complement of each other. Now, here's one thing you need to know. If you have the complement of the other one, it's just the angle minus 90, or 90 minus that angle. So the complement of angle A is going to be 90 minus the measure of angle A. And you'll understand that a little bit more later. Supplementary angles are two angles whose measures have the sum of 180. Now, this one kind of makes sense because of our linear pair postulate. The two angles added up to 180. And notice what we used here. 3 and 4, they're from a linear pair. They're supplementary angles. They don't have to be in the same plane. They just have to have two angles whose measures, not two angles, the angle measures have a sum of 180. Each angle is also called the supplement of each other. Now, here's another thing you need to remember. Supplementary materials in school, you pile lots of extra on. Well, that's what we're going to be doing here. Adding up to 180. It's larger than the complements, which are short and sweet, so they add up to 90. And then supplementary angles, they add up to 180.